Hello, everybody, welcome back. What I've been working on since last time is I separated the main um, loop, let's say, from the land class, the grid. So now there's a specific class for it that handles all the things. I also fixed the purling noise. You see here, the generator. Apparently with these settings, it seems to work much better, creating actual bigger chunks of land. Um, yeah, very minor improvements on the logic of how this is handled. You can see here the changes from the last commit. Yesterday I was working on zooming in and out. Currently it's still a little funky, but I'll work that off camera. Okay, so I wanted to add behaviors to the programs. I don't know if I should create a different class for the program and the program has an identity disk. That way, if for some reason the program loses the identity disk, it starts breaking down like in the series. I think that should be interesting. And better do it now than later, since it's gonna be more work. So yeah, let's. I'm gonna begin doing that. Class. Let's probably this open. This guy has to be declared with an identity disk. Disk. There should be type. I don't know why I'm not getting suggestions. There we go. Type identity disk. Then put yourself identity disk. I hope the keyboard sound's not bothering you, but for now I'm still testing the audio gain. Okay. Then define what. Basically I have to move all this from inside here to the program code. This will read and leave. Let's cut this. Is it here? I think I need a tab. Yeah. And this as well. Okay. Okay. Perfect. Is land or water? I think I moved it somewhere else. I don't remember. Can't see fluid. Oh, here. Invisible grid key. Different in water. Yeah, so I added this because by itself, like random movements, it wasn't going into the water, but actually, it seems right now it can go into the water. Hmm. Calculate direction of target, move one step in one direction. Yeah, here I should add a water check. So I'll just put it as a to do. How to get this? Okay, it's all done now. Okay, now in the identity disk, I wanted to work something. Oh, never mind. Apparently, it already has it. So, yeah, then I should have done refactor instead of, yeah, never mind. Main here. Over. And remove this. Hopefully everything works after this change. To do water check, okay. Move towards, okay, this is for food, I think. Because I'm checking, yeah, I'm giving the target. Yeah, this is for the food. So this needs to, I'll add a comment here. Water check needs to be done before card. Yeah, this is the random move. And yeah, you can see if it's water, then it doesn't do anything. Okay. Now, this identity disk. I was wondering if I could use genetic algorithms. Those are for optimization problems. And using a neural network can work, but if I have 30 programs, this computer is gonna die. Because in Tron Legacy, they show that the ISOs basically have DNA in them. And I could mix genetic algorithms with the network. Okay, let's do genetic algorithms first. So still, we're going to be random movements, but the genes basically will code the suit color, the aggressiveness, all the traits that the programs will have. And then if two programs touch each other, then and have the same color or some random like aggressiveness is low, maybe they can create a new program that inherits those traits. Yeah, so I'm not optimizing for anything. It's just gonna run, and eventually some gene is gonna outperform all the others, right? It should. Now let's see how to actually code this. Let me ask. I'm gonna upload this. Ask over here. We're not seeing this, but it's better this way. I want to add a genetic algorithm to the identity disk class so that each program has its own DNA of sorts. I want to encode Let's see. Suit color. Suit color that can be what are the colors in Tron? That can be blue, white, green. There's also red, orange. I don't think there's any other. Or I don't remember. For now, I'll go with those. Um, what else? Oh yeah, I can encode speed. So would be the stepping size, basically. Let's do it from 1 to 4. Let's call it agility. Then let's add also. I eventually want to add a third dimension to the map, but for now it's gonna remain 2D, so jumping ability is gonna be disabled. Now we can add swim. Swimming. That's gonna be 0 to level 0 means he cannot go in the water. And 1 means he can. So let's just find him. Says this cannot. Okay, yeah, maybe swimming. Yeah, because in the movies they do swim sometimes, but they often fear the sea, or that's my interpretation of it. What else? Suit color, agility, swimming. Let's go aggressiveness. That's gonna be 0 to. Let's make it 0 to 10. And 1 to 10. No, yeah, better 1 to 10. Well, let's make everything 1 to 10. Yeah, also the agility 1 to 10. Stamina. Let's make that also 1 to 10. What are the ones from Fallout special? Is strength, perception. What perception here? Endurance. That's stamina. Charisma. We can add charisma. We can add charisma. Maybe that can de-escalate conflicts. Yeah, charisma. 1 to 10. Intelligence. Yeah, intelligence. I'm gonna need it later on, but I'll just keep it in the back. Intelligence, special, agility, that already added. And luck. Should I add luck? No. Maybe a driving skill. I'm gonna add light cycles and cars and those things. Yeah, agility is just for movement. So movement speed and running and jumping. But then swimming. Yeah, but I need the binary. Aggressiveness, okay, yeah, I need that one. Stamina. Okay, yeah, yeah. Um, Charisma. Yeah. What else? Strength. Yeah, because otherwise I cannot know when a conflict starts. I don't, yeah, I need strength. Yeah. And I can make a nice formula. Mm, maybe, I need some way to measure their ability with disc fighting. Um, okay, maybe I need two sections. One is like genes, and the other is skills. So probably swimming is a skill. It shouldn't be genetical. Agility, I can keep it genetical, at least the base points. Strength is also genetical, charisma is genetical, stamina is genetical, charisma is genetical, and the street color is also genetical. So, genetically, these things and skills. I want swimming, I want motorcycles, or let's call them correctly, life cycles, 0 and skill. And maybe let's make let's make 0 to 9. That's nicer. Just one digit. I know this must be boring just seeing the code screen, but just give me a second and I'll get back to it. 0 to 1 binary and 0 to 9. Maybe next time I'll just share everything. We'll see about that. Light cycles, then there's disk lighting. It's gonna be scaled from 0 to 9. Um, yeah, let's just keep these ones for now. It's stealth. But that's gonna add another complexity. Yeah, but for now, this is good. I'll just add here. Genes to add. It's gonna be I don't know. I don't think there were any of that. And skills. I don't remember the game with the ball. Um, oh, what's the name of the flying things? Darn it. Maybe let's put tanks that I remember there are, and cars. There are also cars. Were they called destroyers? Oh, I don't remember exactly. And what else? Trait decoders. Okay, let's see what this guy's suggesting. I'm gonna copy it so you can see it. Let's see here. Okay, let's see what this guy did do. Suit colors, okay, great. Define init, gym layout, suit 0 to 4, agility, aggression, stamina, charisma, strength, swimming. But he joined everything. I don't want this. Trade decoders, define suit. Return suit color. Oh, okay, so instead of using a dictionary like a normal person, he made it into a list. That's not good. Genetic operations, okay. Yeah, he just mixed single point crossover. And there's our mutation genes, yeah. I remember there was a better, a newer way of doing this. I need to check my notes. But this is the simple one that should returns 2 children. Right, it's just mixing half. Um, yeah, but this is not great structurally. I don't like being like this, that I have to internally know a goal that I'm a secondary personal goal that I'm trying to do is keep everything very interpretable. And this is not it. Okay, let's take some of these ideas and do it correctly. Let's do it. So that genes. It's gonna be the problem with dictionaries that they don't hold order. Um, Ideally the genes are fixed, so they should be tuples. Maybe I can just put the tuple of the name and value and simply access the second one, the second item in the tuple. That's a doable thing. I'm not really sure actually. Because dictionaries, if I have a dictionary, I can just do a key matching and I don't need the order. I think I'm gonna stick with the dictionary. Let's see how it goes. Genes, okay. So first one, I said I wanted suit color. Suit. It's going to be the identity disk also holds all this information. So self suit colors. It's gonna be a this case a list. No, not really. It's gonna be blue. Right. One. I know this is very hard coded, but it's very readable also. So, green. Red and orange. Orange. Dyslexia attack. I think those are all of them. No. Suit colors. Yeah. Red, green, orange. Yep. I think there's also purple, but I'm not sure. But for now, just like that. The suit here is just going to be a random run int from 0 to 9. Circle. So suit colors. There's one. Yes, 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 yes. Yeah, this one. Okay, next one. Agility. I'm just gonna copy this. Swimming is a skill. This fighting light cycle is also a skill. Strength, it's a base strength, and then there's the other skills that they have improved it. I think those are that's the order I said. Suit color, agility, aggressiveness, stamina, charisma, strength. Aggressive, stamina, charisma, strength. Okay. I'm not gonna write everything, so I'm just gonna make a clanker do the dirty, annoying job of fixing the dictionary. Perfect. Okay. Now we have our genes dictionary. That's going to be random. We started now. I need a skills dictionary. You know what? I'm going to keep the skills for another time. I'm just going to add skills dictionary. Okay, now I need to add the mutation capabilities. What is this? I've never seen that function. Okay. Maybe one tab out. There we go. Point. Made into a random. Okay, now here the gene mixing has to be different. I'm gonna do it from random picking instead of yes, exactly. Uniform crossover. Here we go. Exactly what I wanted. Great. But now the issue is this does not guarantee me that there is going to be a mix. The output program could be just cloned, which I mean, biologically wouldn't make much sense, but in the world of Tron, could. I mean, just look at Clue. So basically, if a program is good, so good, or so much randomly, I mean, it's unlikely. So I'm gonna add here to do as a way of weighing parent importance. Let's see. Maybe through another gene like dominance or yeah, i.e. gene dominance. There's probably something about this in the literature. I need to check it. Yeah, we only want one child. Let's call it offspring. Does offspring have two F's? I guess so. Um, but here I think disk needs to receive. How did he handle this? Genes none. Ah, okay. Oh, makes sense. Um, is it called heritage? Let's look it up. Heritage. I think it's heritage to one. Heritage property that is or may be inherited. Yeah. Heritage equal to none. If heritage is none, declare the genes randomly. Else, property is equal to heritage. Okay. And a randomly mutated gene with a given probability. Right. Limits. Yeah, I don't care about this right now. It's always 0 to 9 except for the colors. But the colors cannot be mutated, I guess. And Yeah, the colors can't be mutated. So for I in, let's write this myself. For each in subroutines of things, give random. Ooh, the rate should be declared here. Documentation rate equal 0. Let's make it very low. 0.05. And I guess something like environment can change this. Environment should be able to. It's like with radiation, it's called like cancer, basically. Randomly mutated gene. Okay, give random, smaller than, so that mutation rate. So genes, it's gonna be equal to range rate 0 to 9, and yeah, because if I, let's just stick the key here. Key not equal to okay. Remove this. Return self. Why would you return self? So they have here this thing, and they need to do the define the mutate. Right, this function, it's mutating. This function is mutating the initial disk. Yeah, so let's just call it here so that every time a program is created, they inherit the traits from the parent, initialize everything, and then they mutate at the end of the initialization of their disk. I mean, yeah. So doesn't mutate. Okay. Now, we need to show this thing. So this identity disk, what's this? I have duplicate. I can delete this junk. Okay. Nice. So now the program receives the identity disk. And I can access here, read program. What do you need? It's an edit. project as well then. Disk. Identity disk. And create an instance. Okay. Yeah, eventually I'm gonna need to add a class for objects like food and things like that. Maybe a base class for consumables, let's call them. So that I can keep everything organized. Okay, where's the color of the character? Here, program, cell to color. Program colors sign. Okay. Grid viewer, the color should be here, right? Actually, the suit colors don't need a number. I can just use the. Because I'm not doing summing or anything, I'm just selecting. Agility, yeah, I don't have, it's quantitative, but colors are qualitative, so. Yeah. I'm just gonna. Give me a couple. Sorry, I'm quite lazy on doing these annoying things. And here, instead of doing an int, I don't know, random choice. I never remember the random, it's random choice. Yep. Let's see how it is used. Let's see, choose a random element from a non-empty sequence. Okay, probably just some colors like this, I guess. Yeah. Maybe I should move the suit color out of jeans. It will simplify some things, but well, we'll see about that. Okay. Yeah, so here, when I'm generating a object, set color program, instead of calling cell to color, I just call directly self color. So owners from should be program. generic object dot entity disk dot genes suit and the comma there. Yeah, I know. Probably right now identity disk is not used anymore. I can just go program. My bad. Okay, everything should work. Let's try it. No error. The error red. Oh, right. Need to add the colors here. Oh, and sometimes these guys feel very. This guy's very slow to catch on. So give okay, here we go. And now just keep doing the blue colors and swift colors. As the colors. Okay, finally. Took some effort. Let's see, blue is already there. White, green, red, orange. Okay. Let's see now. If it's running, I'll show you the screen. I was trying to make this work better, but from what I found, there's not really a good way of sharing automatically this thing. Okay, so here you can see I fixed the camera movement, well, it doesn't jump around. As you can see, it also doesn't go into the water. And I can zoom in and out. As long as I don't reach the complete zoom out position, because then it locks there and I cannot zoom back in. I don't know why it's doing that. I need to check again. But okay, now we have a program here with the correct suit color and the genes inside it. Pretty cool. And for now, I'm gonna call it here. Here you can see I zoom out completely. You can see the map is much better than before. Food is also only spawning in the 100 times 100 radius from the, well, not radius, but coordinates from the center. And yeah, I'm trying to zoom in again, but I can't. So yeah, it will be like Hope you like it so far. I hope my voice is a little higher, has a higher volume now. And I hope the typing wasn't annoying. Yeah. I also want to fix the order of the food. Yeah, you just saw that it went through one foot to get the other one. Like, there's no logic in the order. It just does as the code randomly chooses to do so. Yeah. So for now, I'm gonna end it here and see you next time.